Hey, what's up guys, Jeremy here. In this video I will show you how to use the thread feature to have multiple actions taking place at the same time in your virtual environment. Let's get started. In the last few videos we created our pick and scan application. We can now pick an object from the in conveyor using the gripper and an animated gripper. We can bring it in front of the scanner, wait a few seconds, and then drop it on the out conveyor. Now the issue we are facing is the following. If we run our main program, we will go get our bottle, we will move up, then we will ask the conveyor to move forward. The robot is actually waiting for the conveyor to move forward and finish its movement before it can actually go to the scanning position. So that will be even more visible if I bring that back to one-to-one in terms of simulation. So I'm moving up. As soon as the robot motion is done, I will ask the conveyor to move, then the robot will wait for the conveyor to move before moving the bottle in front of the scanner. So that's for sure a waste of time, and we need to fix that. This is what we'll do right now. So the way programs are generated for now, so if we open our pick and scan here, we use here program calls. So this is what we've been using since the beginning. So a program call is pretty much just a call to a subroutine. So I'm going to init everything. So we have go home. So this is a program call. If we call a program call, there's a program pointer that will start at the beginning of the program call, go down and execute all the instructions in this program call. And when the subprogram is done, it will give back the pointer to the main program so that it can call the next subprogram and do the exact same concept. So if we were to go one by one, I will go home here, it will run my move J. When the move J is done, it will come back here, call get bottle in call get bottle in, it will come here, do the first move J, here, do the first move J, do second move L, and then pick the bottle. So yeah, here I need to go the other way around, so I went too fast here. Move L, pick the bottle, and then move up. And then once this is done, now I'm calling next part, and in next part I'm calling this Python subroutine. We'll talk about that in the next video, but it's waiting for the next part subroutine to be completed before jumping to the scan subroutine that requires the robot to move to the scan position in front of the scanner here or the camera. So we can easily modify that and make it go as following. So here there's some subroutines that you want to execute in a linear fashion. So you want some subroutines to be executed, finished before you actually jump to the second subroutine. So this is why this is the default behavior, because most of the time this is what you want. So here in this case, I want to call home and I want the go home to be done before I jump and I start doing anything else. Then here in the get bottle in, I want to have the bottle picked and the robot out of the way before I start moving the conveyor. So that's fine. The issue comes here when I go for call part in. This one I would like to be able to just start, but not wait for it to be finished before I move the robot. So to do that, what I can do is right click, modify, and here there's a drop down menu that we didn't explore yet. So if we click on it, the second option is insert code. So we will cover that later when we discuss how to properly generate robot code for your robot brand. You have here start thread. So this is the one we are interested in. And here you have insert comment. And this is another one that we will discuss later in a future module. So here start thread. If you select this one here and you click OK, you will see a slight difference in the way we are kind of naming stuff and calling stuff. So here you have program calls. So the calls are exactly what as I said before. Program pointer start at the top of the subprogram, goes down, and when it's done, it kind of gives back the hand to the main program for the next subprogram to be executed. Here what it will do instead is, if you see run instead, it means it will start running the next part in subprogram, but will automatically, as soon as it's launched, it will also call the scan subprogram here. So if I do that here, if I run now the way it's built, I'm going back to my home position, get bottle in, As soon as get bottle in will be finished, so I'm moving up as soon as I'm here, you will see 2 program pointers appearing. One here for the next part in, and another one for the scan part, because both are ran at the same time, or running at the same time. Here instead, I didn't change it, so if for this one here, I will retract, and I will have to wait for the conveyor motion to take place before I can move the robot anywhere else. So you will see the difference. So if we concentrate on this part here, coming in, moving up, and as soon as I reach the retract position, both the conveyor and the robot are moving at the same time. So if I want, I can do the same. I'm gonna press escape here to stop all the process. I can do the same for the call next part out. So I can modify in here, come here, select the drop down menu and select start thread. Click OK. We can make sure that the notification occurred the way we hoped for it. So we can see the run here, run next part out. And if I run the main program, we have the init first. Then we move in, pick the bottle, move up, conveyor starts, robot moves to the scan position. We are scanning for a certain amount of seconds or a certain amount of time. Then we move down. I might want to increase a bit the speed here. And the bottle will start moving and the robot starts moving at the same time. So both are synchronous at this point. So that's pretty much everything for this video. I hope you find it helpful. I'm using this method all the time for conveyors, for part feeding, if I have more than one robot. So we'll have a specific video on the topic of how to have multiple robots working in the same station and how to synchronize them. So this is part of module 5, if I'm not mistaken. But here, just like this, I'm using it, like I said, for conveyor, for part feeding, for light. We'll show you some stuff later that are very cool. So yeah, I really like this little feature to improve the general look of the simulation and make it more organic, where everything is kind of happening at the same time, the same way you would like to have it in real life, so that you can have the most efficient or optimized program. Like I said, hope you liked it and have a great day, guys.